Hi, I'm Caroline Stocks with Poultry Health Today, and I'm talking to Chuck Hofacre, who's president of the Southern Poultry Research Group. Thanks for joining us today, Chuck.
Glad to be here.
You've done a presentation at IPPE talking about the effectiveness of reducing Salmonella Infantis. That was also the type of Salmonella that you spoke about in a presentation, another presentation that you've been working on. Why that strain in particular?
Well, last year the Center for Disease Control began to track several foodborne outbreaks of Salmonella, and there were Salmonella Infantis, and they were also multi-drug resistent, multi-antibiotic resistant. It gave them concern, so they highlighted that to the broiler industry that this could be a potential emerging Salmonella for the industry to begin to work on reducing.
You used a Salmonella Typhimurium vaccine in the study. Was it a cross-protection study?
Yes. So Salmonella Typhimurium is a group B, and what we found is that live Salmonella vaccines tend to stimulate the immune system to give protection to other serogroups. The vaccines work extremely well against Salmonella Enteritidis, which is a group D, as in dog. So our hope was that the live vaccine may work well against Salmonella Infantis, which is a group C1. The reason we had this hope was that historically Salmonella Typhimurium vaccines don't work as well against group C Salmonellas, specifically Salmonella Kentucky. We don't see much protection by the live Typhimurium vaccines. So we had hoped that on this one that was a human health hazard, we would get some protection, and so that's why we did this study.
Okay. Can you tell me a little bit about the study, how it was set up and how it operated?
Yeah, so we know that birds don't respond real strongly to live bacterial vaccines, and so we wanted to vaccinate them twice. So we sprayed them at a day of age with the vaccine, and then we boosted it at 14 days in their drinking water. Then at 30 days of age, we challenged them with the Salmonella Infantis. Part of the birds in each pen were challenged, and then the other half of the birds in that pen were allowed to pick up the Salmonella naturally, just as they would in a broiler house. So it's called a seeder bird model. Those birds, we give it to seed it to the litter, and then the pen mates pick it up. So it gives us the opportunity to determine, did the vaccine help reduce the amount of Salmonella colonization in the birds that directly got the Salmonella, and also did it help those birds that were horizontally exposed become infected as quickly.
And what samples did you take? Was it the birds or around the environment?
So we took environmental samples right before processing age, and then we did a feed withdrawal just as the industry would do. We did process the birds, scalded and picked, and did what's called a hot rehang. So we removed the feet and put the bird into a bag and put the broth and did a carcass rinse. So that was the first sample, and then the second sample was internal organs of ceca and liver, spleen.
And what did you find? What were your results?
So what we found was that we had a very high prevalence in the boot socks, and we had a fairly high number of Salmonella in those boot socks of each of the pens. So each pen you could look at as a broiler house. So the broiler house was very positive for Salmonella, which was not surprising. We gave them 10 to the 8 Salmonella at less than 2 weeks prior to the end of the study.
And there was a reduction in birds that weren't directly challenged, but were in the pen with challenged birds. Is that right?
That's correct. So in the internal organs, especially the liver and spleen, we saw a significant reduction in Salmonella in those livers and spleens. The birds both directly challenged and indirectly challenged. The carcass rinses, we didn't see any statistically significant reduction in numbers. We had numerical reduction in both the indirect and the direct, but it wasn't statistically significant.
What's the significance of the reduction in salmonella in the liver or the spleen?
There's two really useful pieces of information that can be gleaned from having lower levels and lower prevalence of salmonella in the liver and spleen. The first goes all the way back to breeders. Even though this was a broiler study, we vaccinate our breeders with the same live vaccines to try to protect those breeders so that they have less salmonella, so that when they become adults and begin to lay eggs, they'll have less salmonella that's colonized their internal organs to get to those broiler offspring. The second is there's been some work at the University of Georgia by Mark Harrison's graduate students to show that internal organ colonization of the liver, spleen, and bone marrow might be a source for salmonella contamination in ground poultry or mechanically separated poultry meat. And so if we can reduce that internal organ colonization, we may have a reduction in the risk for ground poultry products.
Why does reducing colonization indicate that vaccination might be an appropriate way to go?
So the only difference in the study between one group and the other was the live vaccine. So it's fairly conclusive that the live vaccine did have a significant impact, especially on the liver spleen positives.
So what are the practical measures then that farmers should be taking in response to this?
Well, I think if a company is having a Salmonella Infantis or a Salmonella Typhimurium or Enteritidis showing up in their processing plants, this would say that spending the money to live vaccinate your broilers could help you lower that amount of risk that you have from those positive broiler flocks to your processing plant.